Welcome to Unit 5, Lesson 11, Evaluating Logarithmic Expressions Practice Problems. Okay, so select all. That means more than one answer is true that are equal to log 2 of 8. So what does this equal? So if I switch this around, 2 to the x equals 8. I know that 2 cubed equals 8. Okay, so what are all the ones that are 3? So 5 cubed is 125. 10 cubed is 1,000. 10 squared, that's 2. 5 squared is 25. A doesn't work. C doesn't work. 3 cubed is 27. So B, D, E, and 10 to the negative 3. So F doesn't work. B, D, and E work. Okay, which expression has a greater value? Log 10 of negative 100. So this one is negative 2. And 2 to the negative 3 equals 1/8 because 2 cubed is 8. And the negative exponent flips the fraction upside down. So that's negative 3. So which is greater? Negative 2. Now, ironically, you have to remember when dealing with number lines, negative 2 and negative 3 and 0 is right at the red dot. Let's make this a red dot. This is 0. When dealing with negatives, the number closest to 0 is greater because you would rather owe somebody $2 than $3. So 2 is closer to 0, and that makes it greater. Okay, Andre says that log of 55 is 1.5 because 55 is halfway between 10 and 100. Do you agree with Andre? Explain your reasoning. I don't know. Let's calculate the log and see what it is. Ironically, this log is 1.7404. It's actually 36, but I rounded the 36 to 4. So it is not 1.5. So no, I do not agree with Andre. Okay, so we're going to do a little exponent math here. So an exponential function is defined by k of x equals 15 times 2 to the x. Show that when x increases from 1 to 1.25, and when it increases from 2.75 to 3, the value of k grows by the same factor. All right. So what they want us to do here is take k of 1.25 and divide it by k of 1, which gives us 15 times 2 to the 1.25, 15 times 2 to the 1. The 15s cancel out, and we know from the same base that the 15s cancel out, and we know that we have exponents of the same base. Exponent laws tell us that you subtract. So 2 to the 1.25 minus 1 gives us 2 to the 0.25. And let's look at the other one. So if I took 15 times 2 to the 3, and we always take the number to the right, divided by the number to the left, the 15s cancel out again. We're left with 3 minus 2.75, which leaves us with 2 to the 0.25. So it's the same factor. And I don't really have to calculate 2 to the 0.25 because it's really not necessary. Show that when x increases from t to t plus 0.25, k also grows by the same factor. Well, we just did it. Why do we have to subtract again? So basically, what they want us to do is substitute x for t and t plus 0.25. So 15 times 2 to the t plus 0.25 divided by 15 times 2 to the t. The 15s cancel out. We get t plus 0.25 minus t, because when you divide the same base, you subtract the exponents, and you're left with t to the 0.25. Okay, how many times does $1 need to double? So $1 is our start, that's our A, times 2 double is our factor. Now we're going to put this into the calculator and see when it gets to $1 million. Okay, and if we go down, remember our X is years. Well, it just say how many times it needs to double. So we don't know what X is. So whatever. X is some moment in time. We don't know what it is. At 20, we see when X equals 20, Y equals 1.05 E6. Now, E means times 10. So what that means is scientific notation. You move the decimal 6 times to the right. So 1.05, you move it 1, 2, 3, 4, 5, 6. Put zeros in the humps, and you'll see $1,050,000. So if you let the money double 20 times, it'll get over $1 million. At 19, it was at $524,288. That's not quite enough. Okay, so what could replace the question mark in these to make them true? So this is easy. There are 4 zeros in this one. There are 7 zeros in the second one. Now, we're going backwards. We have the answer. We have the exponent. We need the answer. So put a 1 and put 5 zeros after it. All right. With D, we have the answer. We have the exponent. We need the answer. Put a 1, put 1 0 behind it. What value of t would make the equation 2? We don't know what t is, and when we don't know what our exponent is, we're going to use log, but this is base 2. So now we have to write log base 2 of 6 equals t. And now we're going to hit the math button. We're going to scroll down to A. I'm going to put 2, right arrow, hit 6, hit enter. And t is going to be 2.58496. Now watch this. Because it's 49 and 6 is next to the 9, to the right of the 9, this has to go to 50. So this is one of them odd cases where you have 9s. You have to keep pushing numbers up to the left. After 49 is 50. Between what two whole numbers is the solution for t? Well, t is bigger than 2, but it's less than 3. Because 2 squared equals 4, and 2 cubed equals 8, and 6 is in between 4 and 8. Okay, now for this one, all we have to do is write it in equivalent logarithmic form. So when we write in log form, the base stays the same. It just goes down below. The answer and the exponent change because logs count exponents for C. For D, and for E. So basically, to go from exponential form to log form, the answer and the exponent change. To go from log form to exponential form, the base comes up and the answer and the exponent change.